Now we're going to work on problem 10-4. This says, now reverse the process. If you know the volume, so volume is created by multiplying a number 3 times or cubing it. If you know the volume, how long is the side? So we are given below the volumes for different cubes, and we're supposed to find the length of each one of these, of a side of each one of these cubes. So we're going to do something similar to what we did with square root. So if we wanted to find a square root of a number, or if we wanted to solve this equation, we had x squared and it was equal to 16. How do we find out what x was? We would reverse the squaring by finding the square root of both sides. So x squared is x times x. So finding the square root means finding a number which is multiplied by times itself twice. So the square root of x squared is just x. Similarly, over here, the square root of 16 can be broken down to the square root of 4 times 4. So the square root, which is a number multiplied by itself twice, the square root of that would just be 4. So we'll do the same thing with these cube roots. So for instance, if we have a cube root of 8, and we signified the cube root by using the square root symbol, but this time we put a little 3 in it. So now we're looking for the cube root of 8, or a number which is multiplied times itself 3 times to get this number. So in this case, 2 times, or 2 divided into 8 once is 4, and then 2 divided into 4 is 2. So we can factor 8 into 2 times 2 times 2. So that's multiplied by itself 3 times. So the cube root of 8 is just 2. So we can do that for all of these numbers. But just as with the square root, we have a special key on the calculator to do that. So we have, okay, so here we have a square root, which is the square with a 2 in it, and we also can find a cube root. For instance, if I wanted to find the cube root of 8, I would put 8 in, and then I would choose this function, which is the cube root, and I would find that the answer is 2. There's also a way that you can find cube roots without using a calculator. For instance, let's look at this number, 125. So if we can factor 125 out completely, then we will be able to find the cube root. So 125 divided by 5, which is a prime number, is 25. And then 25 can be divided by 5 again, and we're left with 5. And then 5 can be divided by 5, and then finally we get to 1. So right now we know that the cube root of 125 must be 5, because if we multiply 5 times 5, we get 25, and 5 times 25, we get 125. So there's the cube root of 125. And we can do the same thing with 1,000. So 1,000 is actually fairly easy because we know so much about multiplying tens. So if we divide 1,000 by 10, we'll get 100. And then if we divide 100 by 10, we'll get 10. And if we divide 10 by 10, we'll get 1. And so the cube root of 1,000 is, here we've got 3 tens multiplied times each other will make 1,000. So we know the cube root of 1,000 has got to be 10. This number is a little more difficult because it is not a perfect cube. So in this case, we'll use our calculator. So we'll put in 40, and then we'll choose the cube root function. And we find out that, yes, indeed, it is a rational number. It's not a perfect cube. It's 3.4 and probably 2. We'll round up that last number. Oops. So 3.42 is close enough to the cube root of 40.